Dynamics of fluid flow for fluid machinery. So, check yung figure. So, yan ang i-discuss natin. Abot tayo dyan. So, na-discuss na rin ito sa fluid mechanics niya. So, introductions. So, in this topic, the forces exerted by fluid particles on the surfaces over which they flow is discussed. In case the surfaces cause a change in magnitude and direction of the velocity of the fluid particles, the fluid particles exert a force on the surface. In turn, the surface exerts an equal and opposite force on the particles, like elbow, T, reducer. So the forces exerted by moving fluid particles on the surface is called the dynamic force. Dynamic force always involves a change in the magnitude and direction of velocity of the fluid. When applied to a single body, Newton's second law can be started as the sum of forces on the body equals the rate of change of momentum of the body in the direction of the force. So in equation 1, from F and B, dito, F and B are in the same direction. So summation of F is equal to derivative of mv over T. Okay? So dito yung mass is in kilogram, for example. So dito naman, so this can also be written as summation of F dt is equal to derivative of mv, where m is the mass of the body, and b is the velocity of the body, and t is the time. Like note, the mass is in kilogram. This also means that the impulse F delta t equals the change in momentum of the body during the time delta t. So when applied to control volume, so through which the fluid is flowing, the principle can be stated as the sum of the forces on the fluid equals the difference between the momentum flowing in and momentum flowing out, and the change in momentum of the fluid inside the control volume under steady flow conditions. The last term vanishes. Since the forces and the fluid is given by summation of F dt is equal to derivative of mv out over with respect to t minus derivative of mv in with respect to t. So ang nabanis dito is yung change in momentum of the fluid inside the controlled volume under steady flow condition. Yan. Ito nang nawala kasi steady flow siya. So in other words, the net force on the fluid mass is equal to the net rate of outflow of momentum across the control volume. So this can also be written as the summation of F is equal to root 2 Q2 B2 minus root 1 Q1 B1. If the fluid is incompressible, like sa water, then summation of F is equal to root Q delta B. Pag compressible siya, so ibang application na yun, nasa gases na yan. So in this case, delta V should be taken as the vectorial addition of V1 and V2. So vectors. And the force will be in the direction of the resultant of V1 and V2. So in cases, the forces in the Cartesian coordinate, Cartesian direction is required. The equation in scalar form is written as summation of fx equal to rho q delta u, summation of fy is equal to rho q delta v, summation of fc is equal to rho q delta w, where u, v, and w are the components of velocity in x, y, and z direction. Hindi ko na-explain yung u, v, w, x, y, z. Meron namang i, j, k. Alam nyo na yan. Next, the impulse mo. When calculating the momentum flowing in or out, if the velocity over the section is not uniform, a correction has to apply. The correction factor beta is given by beta is equal to 1 over AB squared times the integral of U squared dA, where V is the average velocity. So pag nagabari yung velocity. Next is the force exerted on the pressure conduit. So pressure conduits yung may mga pressure. Di ba yung ano siya, full. So, figure 1, ito yung sa A, ito yung reducer. Then, control volume niya, ito yung sa letter B. Andyan yung free body diagram. Consider the reducer section shown in figure 1A. The free body diagram is given in figure 1B of the control volume ng fluid. Assuming ideal fluid flow, summation of Fx is equal to P1A1 minus P2A2 minus Fx equal to rho Q times U2 minus U1. Or the force on the fluid is given by Fx equal to P1A1 minus P2A2 minus rho Q plus U2 minus U1. Capital P ang gamitin natin sa pressure dito kasi yan sa reference. Now, the force is the force exerted by the reducer on the fluid in the x direction. Yan, kaya opposite siya. So, di ba, pag pupunta ton, itong to, nag-move doon, so may force, yung pressure dito, itong action niya. Yung action ng pressure dito sa area yan, sa area to. So, meron siya ditong reaction. This force acts toward the left as assumed in the figure. The negative sign in left-hand side of the equation 10 is due to this assumption. Ito sinasabi. The numerical value will show the actual sign. Kung na-compute mo is negative, so mag-reverse yun. Now, the force exerted by the fluid on the reducer will be equal and opposite to this force Fx. The plus and minus sign used in the equation depends in the positive direction and the negative direction, vectors. So, positive papunta dito, ito yung negative papunta sa left. In case both the magnitude and direction of the velocity is changed by a reducer bend. Bend to na nag-reduce. Okay. Then the force exerted by the bend on the fluid, the turning angle being theta. The suffix F indicates as on the fluid. Sabi itong F na to, sa fluid. Fluid tayo. Ito kita yung sa loob na head na yan ang kinoconsider nating control volume. So, let theta is 45. Sa example kasi to. So, the forces on the band will be equal and opposite to these forces. So, example number 1. So, back to this figure. Dapat nalipat natin to. Ayan. Yung figure 1 na yan. Okay. Tandaan niya. Screenshot. A reducer on the horizontal plane has an inlet area of 0.02 meters squared and the outlet area is 0.01 meters squared. This velocity at the inlet is 4 meters per second. The pressures are 40 kilopascal at inlet and 10 kilopascal outlet. So, determine the force exerted by the reducer on the fluid. So, given A1 is equal to 0.02 meters squared, A2 is 0.01 meters squared, U1 is 4 meters per second, P1 is equal to 40,000 Pascal, and P2 is equal to 10,000 Pascal. Oh, di pa napalitan to. So, from figure 1, as the flow is in horizontal plane, body forces are neglected. So, refer to figure 1. U2 is equal to A1, A1, U1 is equal to A2, U2. So, U2 is equal to A1 over A2 times U2 is equal to 0.02 over 0.01 times 4 or 8 meters per second. So, using equation 11 ba yun? 1. Ang layo na. Okay, balikan na lang. So, Fx is equal to P1 sa equation 1 to. Check na natin. Okay. So, equation 11 nga. So, Fx equal to P1A 1 minus P2A2 minus M times U2 minus U1. Take note, yung M natin dito is the mass flow rate. M dot. Di ko nalagyan doon. So, rho A1, U1 is equal to 1,000 times 0.02 times 4 is 80 kilogram per second. Substitute pressure as in Pascal, Newton per meter squared. Okay, 40,000 times 0.02 minus 10,000 times 0.01 minus 80 times 0.8 minus 4 or 380 Newton. Eh, so Fx is equal to 380 Newton on the fluid towards left. Same son sa figure 1 natin. So on the reducer, 380 Newton along positive X direction. Ito yung force niya papunta doon sa reducer, yung bakal. O siya rin pupunta doon sa bearing niya. So example number 2, a 45 degrees bend in the horizontal plane is shown in figure. So the inlet area is 1.2 meters squared and the outlet area is 0.6 meters squared. So the velocity of water at inlet is 12 meters per second. So the pressure at inlet and outlet are 40 and 30 kilopascal respectively. Is outlet. So calculate the magnitude and direction of the resultant force on the band. So this is ito yung figure 2. So parang di na-discuss masyado kanina. Ito nga, discuss nga to. Ito yon. Eh? So required is the magnitude and direction of resultant force. See the drawing? This is natin sa next slide. So solution, for convenience, the control volume, this one, so yan nga, yung naka-hidden line, should be chosen such that the inlet and outlet area, number 2, are normal to the velocities at this section. It is convenient to calculate, in this case, the force on the bend is required. So, yung direction niya is later na. It is convenient to calculate the forces in the X and Y direction separately. So, given natin muna is B1 is 12 meters per second. B2 is 24 meters per second. Yung lumabas dito. Wait. Yung lumabas dito yung velocity B1. Ito naman B2. Ano? Yan yung velocity. Okay? Then, the mass flow rate is rho A1 B1 is 1,000 times 1.2 times 12 is 14,400 kilogram per second. Yan. Given ba yung... Okay, so wala ditong B2. So B2, nakuha mo yun sa A1 dito. A1 B1 is equal to A2 B2. Okay? Yan. A1 B1 is equal to A2 B2. So masolve mo to. Now, using equation 1213, f sub x is equal to P1 A1 minus P2 A2 cosine theta minus M dot times B2 cosine theta minus B1. So ito, paano mo pagbura niyan? Erase. Ayan. Panggal. So, Fy is P2 A2 sine of theta plus M dot B2 sine theta. Okay? Take note, yung direction ng Fx mo dito is punta doon. Fx. And Fy is pataas. Yan. Yan ang direction mo ng assumption mo dito. Okay? Okay. Obvious naman siya, di ba? Kasi nag-equal siya. So, mag-o-oppose to. Yan. Substituting the values. So, Fy pala is equal to P2 A2 sine of theta plus M dot B2 sine theta. Okay. So, ito, meron kang force dito na P2 A2. Yan ang force mo. Tapos, yung theta mo is, itong angle na yan is theta. Pangit ng drawing. So, the force times sine theta, ito na yung vertical component, y component ng P2A2. Yan. Okay? So, Fy, then, so, ito naman M times B2, so, yan ito. Okay? So, since formula mo is so, Fy minus P2, yung component na yan, P2A2 sine, na-derive na rin yan, di ba? So, yun na natin ulit. Explain natin. Is equal to the change of delta of MB. So, ang B2, ang B1 mo vertical is 0. B2Y minus B1Y. This is 0. This is B2Y is B2 times sine of theta. Okay, M times B2Y. So, ito na yon. So, itong minus pupunta sa kabila, kaya sa mag-add. Okay? So, yan. Finish natin. Mm. Mm. Ayun. So, substituting the values, force in the fluid is Fx equal to 40,000 Pascal times 1.2, yung area square meter, minus 30,000 times 0.6 times cosine of 45, minus 14,000 times 24 cosine of 45 minus 12. So, Fx is equal to 36,300 Newton or 36.3 kilonewton in the negative x direction. Yan, sinabi ko na kanina. Then Fy is equal to 30,000 times 0.6 times sine of 45 plus 14,000 times 24 times sine of 45. So Fy is equal to 257,100 or 257.1 kilonewton in the positive y direction. So vertical upward. So the forces on the bend will be 36.3 kilonewton along x and 257.1 kilonewton downward. Opposite. Di ba? Yung sa fluid, yun yung sanagot natin. Yung sa bend, so ito na yon. So the resultant is F is equal to the square root of 257.1 squared plus negative 36.3 squared is 259.65 kilonewton. So this is now the answer. In the negative x, kaya negative ito. Diba? So yan. So opposite, The direction is theta prime is arctangent of 36.3 over 257.1 is 8.04 degrees with the negative y direction. So this is, ang tanong kasi dito is, calculate the magnitude and direction of the resultant force on the bend. So, kaya babalik natin yung sign para maging sa bend siya. Pag itong positive, naging sa positive, sa computation is sa fluid. Pag ang required is sa bend, so i-negative mo siya. Yeah. So, kaya ito, 257.1 downward. Sa bend siya, sa bend. Then, 36.3 instead na papunta sa left, ito na siya. So, yung angle na yan, itong theta is 8.04 degrees. Yan yung direction. Okay? Ingat kayo dito. So, ang sagot ng computation mo, yun ang final sagot mo. So, balikan mo yung question, yung required. Yung pala, yung bend o yung elbow, yung reaction doon sa elbow ang tinatanong. Tapos, maigpit pa sa sign, positive or negative. Yeah. Now, force exerted on a stationary vane or blade. Stationary, di pa sa gumagalaw. Yung parang, yan. So, in turbo machines, the blades are in motion. To start the analysis on a stationary vane is considered. Here, the direction of the velocity is changed. There is negligible change in the magnitude. So, in this case, considered pressure forces equal both at inlet and outlet kasi wala siyang enclosure. The flow is assumed to occur in horizontal plane. Yan. Hindi yun yung horizontal yung nakikita nyo. Hindi yan yung nakatayo. Tapos, di ba? Yung B1 tapos yung B2 pumunta sa langit. Yan. Hindi ito. Ano lang to, horizontal. Forces along X direction by the blade on fluid with the assumed direction. Assuming B sub 2 is equal to B sub 1 as no other energy transfer occurs. Di ba? This is now B1 is equal to B2 kasi wala kang area. Walang pressure. So, then, negative, check nyo yung free body diagram on the water. Okay? So, negative Fx is equal to the change in momentum. M2 times B2U minus B1. This is component at x-axis. Is equal to M dot times B2 cosine theta. Diba? Yan. Angle niya. Ayan, yung theta. Yan. Is equal to M dot B1 cosine theta minus B1. Kasi B2 is equal to B1. Yan. Parang ito yung absolute velocity niya. Later. Kung tayo mga absolute, relative, yan. And tangential. So, By is now is equal to positive sa vertical B pataas. M times B sub 2y minus B sub 1y. So, B sub 2y. So, B sub 1y. B sub 2y, ito yon. This is B sub 2 sine of. Yan. Ito yung B sub 2u. Ito yung B sub 2y. So, yeah. So, B sub 2y is equal to B sub 1 sine theta. B sub 2 sine theta original. Then, dahil equal to, yung B sub 2 sa B sub 1, so ito na siya. B sub 1 sine theta. So, naka-close pa rin siya. Okay? Minus 0. Kasi B sub 1 umay mo, wala kang component dyan. So, 0. So, ito na yung, ano mo, yung formula. Tanggalin ko tong mga erase all. Yan. Kamasig. So, example number 3. So repair tayo dito sa figure 3 hindi ka na nalipat. So a blade turns the jet of diameter, the jet, yung water jet, 3 centimeter at a velocity of 20 meters per second by 60 degrees. Determine the force exerted by the blade on the fluid. So given, yung diameter mo is 3 centimeter or 0.03 meters. Divide mo siya ng 100. Eh. So the velocity is 20 meters per second. Theta is 60 degrees. Required force exerted by the blade on the fluid. Yan. So, kung ano yung sa formula, yun. Kasi yun ang required niya eh. So, hindi yung force exerted by the fluid on the blade. So, binaliktad yun. Yeah. So, yan. Basahin niyo palagi yung required. Baka pag solution na trick kayo doon. Okay? So, rate of flow, m dot is equal to pi d squared over 4 times b times rho. Ito yung diameter ng jet. Kumukuha mo yung flow doon. So, yung jet, pag after ng jet, wala na. Open na siya. Doon na siya sa blade na. Kaya hindi siya pipe, kaya nga jet eh. Pag guided siya, so pipe yon. So, negative fx is equal to m times b1 cosine theta minus b1. Substitute na yung values. Negative fx equal to 14.14 times 20 cosine 60 minus 20 is negative 141.4 Newton. Or 141.4 Newton in the assumed direction. So, pwede mo inote. Huwag kang sagot ng sagot. Tapos, pinopya mo, yung sign mo, mali. Pwede mo tanggalin yung sign, maglagay ka ng ito, in the assumed direction. Parang, siyempre, pinag-check yan. So, Fy is equal to MB1 sin theta. So, ang M natin is 14.14 times 20 times sin 60 is 244.9 Newton. So, the forces on the blade are 141.4 Newton along X direction and 244.9 in the negative vertical direction. So the resultant is 141.4 degrees squared plus 244.9 square root nyo is 282.8 Newton. So this answer. And the direction niya is arctangent of 141.4 over 244.9 is 30 degrees. Okay? Yung theta dito is fx over fy. Yung sa kabilang side, yung theta binabanggit is yung angle nito, Yan. Yung theta, ito. Iba itong theta dito, sa ano natin. Sa forces, ang theta niya ito. Yan. Fx over Fy is tangent. Fy. Fx over Fy is tangent. Theta. Nung resultant. Yan. Kami sa niniwasan magpagamit ng doble-dobleng symbol. So dito, di maiwasan kasi nga sa forces yun. Ito naman sa blade. Yan. So theta is not, hindi ito. Okay? Kaya katabi naman siya doon. Next is the absolute and relative velocity relation. So, naman natin yung basic doon sa mga diagram. Velocity, yan, dynamic of blades. So, absolute and relative velocity relations. Ito naman. Dito na, papasok yung multiple blades. Right, Now, for absolute and relative velocity relations. So, in order to determine the process on moving blades and the energy transfer between the blades and the fluid, the relative velocity between the fluid and the blade becomes an important factor. So the blade may move in a direction at an angle to the velocity of the fluid. The relative velocity of a body is its velocity relative to a second body, which may in turn be in motion relative to the Earth. So the absolute velocity v of the first body is the vector sum of its velocity relative to the second body, v, and the absolute velocity of the latter, u. So vectorially, v is equal to u plus v. Vector addition. Okay. Ito yung blade. Dito stationary. So ano yung discuss naman natin is yung moving. So this is easily determined by vector diagram called the velocity triangle or velocity diagrams. Some possible diagrams are shown in figure 4. So this is the absolute velocity. This is the blade velocity. And this is the relative velocity. Ito yung relative. Okay. This is a VU. So this is for beta. Less than 90 degrees. Ito naman yung beta mo is more than 90 degrees. Yung alpha, ganun din. So dito sa unang dalawa is less than 90 degrees. Ito naman yung alpha at beta more than 90 degrees. So tandaan nyo itong mga velocity diagram. Okay? So later, this ano yung B, absolute velocity, B, and the blade velocity. Ito yung relative velocity ng absolute sa blade. Yung difference ng velocity nila. Diba? Ito is the component of absolute velocity in line sa blade or tangential. So, some of the general relations are B times sine alpha is equal to B, small letter b, yung relative times sine beta. Letter change yung ano natin yan, yung symbol ng small letter b. So, BU is equal to B cosine alpha is equal to U plus B cosine beta. Okay. Ito. Yan ang general relation niya. U plus B cosine of beta. Pagdating dito, siyempre, maging negative to. Sa kabila, so mama-minus. Kaya ang BU mo, lumiit kaysa U. Okay? So tama yung sign mo. BU is the component of absolute velocity of the first body in the direction of velocity U of the second body. Yung second body mo is yung blade. Yung first body mo is yung B is yung water. Now, next is the force on a moving blade or moving vane or blade. So, ayan, kita nyo ang itsura ng blade dyan. So, the force on a single moving vane, single lang is rarely met. So, but this forms the basis for the calculation of force and torque on a series of moving blades fixed on a rotor. So, dito madiderive yung mga pump work, turbine work. There are two main differences between the action of the fluid on a stationary vane and a moving vane in the direction of fluid motion. In case of the moving vane, it is necessary to consider both the absolute and relative velocity. So ito, yung alpha mo is 0. Diba? Yan. So ito yung sa inlet, sa entering, ayan, B1 is equal to yung blade. Yung difference niya, yan, ito na yan, BR na. Yung small letter B natin. Is B minus U. Sa outlet, ito naman ang magiging itsura niya. Yung absolute velocity mo, iyan, yung blade niya. Yung relative, ito, and the blade, same nito, yung value. Tapos yung beta 2, yung angle ng pagka-bend mo. Yan, beta 2. Kasi sa, yan. Ito yung rotational. Okay? So, ito naman is yung relative. Andyan yung beta. Sa absolute, andyan yung alpha. Ito. Ang alpha mo, ito yan. Ito ang alpha mo, yan, yan, yan. alpha. Okay? Oh, yun na anong mga animation na natanggal. So the other difference is that the amount of fluid that strikes a moving vein at any time interval is different from that which strikes the stationary vein. And the other difference is that ng moving sa fixed stationary is that the amount of fluid that strikes a moving vein at any time interval is different from that which strikes the stationary vein. If a jet of areas A with a velocity v1 strikes a stationary vein, the mass impinging per unit time on the vein equals rho A v1 kilogram per second. Wala na. Yan. But when the vein moves away from the direction of the jet with a velocity u, so malayo rin siya, then the mass of water striking the vein equals rho A times B1 minus U. So yung pagkaiba ng moving sa peaks. So the B minus U is the relative velocity between the jet and the vein. So this can be realized when we consider the velocity of the vein to be equal to that of the jet. In this case, no water will strike the vein. Obviously, consider the flow as shown in figure 5. So the velocity diagram with as inlet and outlet are shown on the figure. So lagi mong gagawin yan. Consider the force on the fluid in the direction of blade velocity can be considered as x direction. So Fu is equal to negative rho u times B1 minus u times BU2 minus BU1, denoting BR as the relative velocity. So it BR which is B1 minus u. So BU2 is equal to BR2, yung derivation nun ano na sa ibang slide. So BR2 cosine beta 2 plus U. Diba dito? BU2, ito yung ano mo, ito yung BU2. Yan. Is equal to BR2 cosine ito plus U. So lalabas ito. Kasi cosine ito is magiging uh, negative. So plus U, ito positive doon. So ang result niya ito. Okay? Check nyo na lang. So, ito, Fu is equal to negative rho A times B1 minus U times BR2 cosine beta 2 plus U minus BU1. Yan. So, in this indication, BU1 is equal to B1. So, ibig sabihin 0 degrees yung alpha. So, yung angle doon. So, it is possible that B sub R2 cosine beta 2 or plus U or BU2 is negative depending upon the relative values of U and BR. That is, U is greater than BR2 cosine of beta 2. So it is to be noted that the vane angle at the inlet should be in the direction of the relative velocity of the water when it touches the vane. Otherwise, loss will occur due to the jet hitting the vane at an angle and then turn on the vane surface. So it was assumed that the relative velocity at the inlet and at outlet are equal as no work was done by the vane on the fluid. Yan. V sub R2 is equal to V sub R1. Yan. So ito, lagyan mo na lang ito ng 1. 1. This is V sub 1. Okay. Sa mga libumin, nawawala rin kasi yan sa reference natin. So in case of friction, B sub R2 is equal to C times B sub R1, where C is a fraction. In case the beam moves at a different direction from that of a jet velocity, say at an angle alpha, then the force on the fluid on the vane will be at an angle. Yung alpha 1 kanina, yun, hindi sa equal. So, meron ng component to. So, in such a case, Fx is equal to rho A times B1 cosine alpha 1 minus BR2 cosine beta 2 minus U times B sub 1 cosine alpha 1 minus B sub U1. Or rho A times B1 cosine alpha 1 minus B2 cosine of alpha 1. So, wait, parang may problema to. So, ito, yung mali nga. So, Fx is rho A times B1 cosine alpha 1 minus B2 cosine of alpha 2 times B1 cosine of alpha 1 minus B sub U1. Okay? Ano ba yan? So, to. So, as it was already mentioned, a single moving blade is not of practical importance when a series of vanes fixed on the periphery of a well is struck by the jet. So, then the mass of fluid striking then when will be rho A, B itself. Kung gamma yata. Work or energy transfer between the fluid and the water will be F times U. So, yun ang tinatawag na energy transfer or yung work. So, ito sa single moving, may minus to, di ba, ng U. So, yan yung figure 5. So, example number 4. A 4 centimeter diameter water jet with a velocity of 35 meters per second impinges on a single vane, moving on in the same direction at a velocity of 20 meters per second. See the figure. The jet enters the vane tangentially along the x direction. Ito. The vane deflects by the jet by 150 degrees. Ito nyo to. Ayan. Calculate the force exerted by the water on the vane. Yan. So, D is equal to 4 centimeters, 0.04 meters. B1 is 35 meters per second, and U is 20 meters per second. Vane deflection, 150 degrees. So, required the force exerted by the water on the vane. So, gawin nyo itong sa inlet velocity diagram. Ito yan. May mga binigay naman tayong drawing, di ba? Outlet, so ito yan. Yung B, papunta doon. This is 150. Yung BR mo, yan, pumasok doon. Yun din ang lalabas doon. Yan, ito yung angle niya. Yan, yung BR. So, this is 150. So, ginawa na lang ng 30 dito sa loob. So, bala kayo kung anong forms pa convenience sa inyo. Basta yung general equations, ito. Equal naman siya. So, velocity, ito naman yung absolute velocity ng water. Okay? Yung actual na nakikita nyong takbo ng water. Relatively, papunta sa dito, pero sa actual makikita nyo pag malayo, papunta doon. So, the relative velocity is given by BR1 is equal to B1 minus U is 35 minus 20, 15 meters per second. And B sub U1 is equal to 35 meters per second itself in the direction of the blade velocity. So from exit velocity triangle or exit or outlet, B sub U2 is equal to U plus B sub R2 cosine of 150 or U is minus BR2 is equal to cosine of times cosine 30 based na dito sa ginawa mong 30. So, B sub u is equal to 20 minus 15 cosine of 30 is 7 meters per second. So, this one. Yan. B sub u2. So, this is in the same direction as B sub u1 or B1. So, delta BU is equal to B sub U1 minus B sub U2 is 35 minus 7 is 28 meters per second. So FU is equal to rho A times B1 minus U times B sub U1 minus B sub U2 is equal to, so the density is always 1,000 kasi wala tayong given temperature. So, 1,000 times pi times 0.04 squared over 4 times 15 times 28. So, 15, ito na yun sa taas. And 28, ito na yan. So, this is 527.8 Newton. Ito na yung force. Yan. So, energy transfer rate, FU times U. So, 527.8 times 20 is 10,556 Newton meter per second or watts. The Y component, Fy is equal to 1,000 times pi times 0.04 squared over 4 times 15 times 15 sine 30 minus 0 is equal to 141.37. Note that B sub 2 sine alpha is equal to BR2 sine beta. Yan ang mga identities dyan sa triangle. In case series of vanes have been used, Fx equal to 1,000 times pi times 0.04 squared over 4 times 35 times 28 is 1231.5. So energy transfer is 1231.5 times 20 is 24,630. So this part, ang solution mo lang is itong part na to, may answer ka na dyan. So ito is extension na lang to, hindi naman kasi required. In-explain lang, okay? In case na series of vanes, so ito magiging energy transfer mo. So hindi ito part ng problem. Extension lang. Part of extension lang to ng solution. Yung required mo, ano na yun, 528 Newton. In case there is friction or for the flow over the blade, B sub R2 is equal to CBR1. Okay? Yung pumasok ng BR1 dito is also BR2 is C times BR1. Yung pagdating, ito na. So, in case the water jet direction and blade velocity direction are at an angle alpha 1, then at the inlet, B sub U is not equal to B sub 1, but will be B sub U is equal to B sub 1 cosine alpha. Yan, hindi siya 0, kundi may angle siya. May ganun. Ganyan siya. Pumasok. Pumasok dito. Yan, pag ganun. Next is yun pagkuha yun ng forces. Saka yung work. Next, the torque on a rotating wheel. So, kailangan to pag sa pump saka sa turbine. Blades or vanes may be fixed at the periphery of the wheel. Yung kaninang well doon, hindi yung balon. Ito pala yung spelling nun. Well. Ito. Nawala. Sige, basta nandyan yun. So there are cases where the blades are fixed at the sides of a disc, such as the radius at which the fluid enters the vein will be different from the radius at which it exits. So the former type is known as axial blading, and the latter type is known as radial bleeding. Ito yung radial bleeding. Sabihin, yung radius niya, nag-iiba-iba. Yung sa axial, so, yun yung sa mga sa propeller. So, madali lang yan. So, dito, diniscuss lang is yung sa radial braiding. Nag-iiba-iba kasi yung radius niya. So, meron tayong U1, U2, U3. So, in the former case, the blade velocity will be constant doon sa axial braiding. In the latter case, the blade velocity will vary with radius. Dito na sa figure 7. Thus, the force on the blade will vary with the radius and the previous method cannot be used to find the fluid force on the blade. In this case, the moment of momentum theory is used to determine the torque on the wheel. So the theorem states that the torque on the wheels will equals the rate of change of momentum of the fluid as it flows over the blade. Thus, it is necessary to determine the moment of momentum at the inlet and outlet to determine the torque. Torque can be produced only by the velocity component along the periphery. So the components of the velocity in the tangential directions, yun nga, tangential, are BU1 and BU2 is equal to B sub 1 cosine alpha 1 and B sub 2 cosine of alpha 2. Momentum at entry is MB1 cosine of alpha 1. Momentum of the of entry is MB1 cosine of alpha 1 times R1. Okay? Yung yung momentum mo is MB. So, kami yung cosine. Pag binultiply mo siya ng radius, magiging moment na siya. Di ba? Force times distance, radius is the moment then, di ba? Or torque. So, similarly, moment of momentum at exit is mb2 cosine of alpha 2 times r. So, the torque is equal to m dot times r1, b1 cosine of alpha 1 minus r2, b sub 2 cosine of alpha 2. So, ang entry mo dito, yan. Sige doon. This is sa ano to, sa turbine. Turbine yata. Eh, oh, sa turbine to. So, pag dito ng entry mo, palabas sa pump yun. Okay, double check. So, power is W times 2, yung omega. W is 2 pi and over 60. So, makukompute mo na yung power. Sa pump to, sa pump, sa turbine, yung sa blades. Didivide mo pa siya ng mga hydraulic efficiency, kung ano pang mga efficiency, lalabas na yung motor. Okay, substituting 2 pi r1 n over 60 is equal to u1. The tangential velocity at n3, 2 pi r2 n over 60 is equal to u2 is the tangential velocity at n3. So p is equal to m dot times v sub u1 minus v sub u2 u2, where v sub u1 and v sub u2 are the components of the absolute velocities of the fluid in the tangential direction along the u. Same siya. In this case, the direction of blade velocity is the tangential direction to the wheel on which the blades are fixed. So example number 5. Blades are fixed in a disc with outer and inner diameters of 0.8 meters and 0.4 meters. The disc rotates at 90 RPM. The flow rate to the blades is 4,000 kg per second. The inlet angle of the blade is 80 degrees and inlet angle. The blade width is of the blade. The blade width is 0.25 meters. If the flow at outlet is radial, determine the blade outlet angle. So blade, at is yung mga ano yan, mga beta. Pag blade, letter B, so beta yan. So alpha is absolute. Determine the angle at which the water should flow for smooth entry. Ang liquid dito is yung alpha 1. Determine the torque exerted and the power resulting therefrom. So given, D1 is 0.8 meters, D2 is 0.4. Base tayo dito sa figure. N3, mas malaki. May N10 naman na sa gitna, palabas yun sa pump na yun. So if the flow, ayan, N is 390 RPM. So tama, turbine nga to. Mass is 4,000 kilogram per second. Inlet angle of blade is 80 degrees, which is beta 1. Blade width is 0.25 meters. Gagamitin natin yan pagkuha ng mamaya sa area. Require the blade outlet angle. Angle at which the water should flow for smooth entry. Blade outlet angle is beta 2. Yan. The angle at which the water should flow for smooth entry is alpha 1. Then the torque. Yan. Alam niyo yung mga required. So, solution, o natin yung mga velocity, yung blade. U1 is equal to pi D1 N over 60 is equal to pi times 0.8 times 390 over 60 is 16.34 meters per second. U2 is equal to U1 times D2 over D1 or same equation, no? Pi D2 N over 60. Magiging 16.34 times 0.4 over 0.8 is 8.17 meters per second. For continuity, the flow is Q is equal to pi dB BF. Where BF is the flow velocity along the radius. Di ba? Yung radial siya. So, yung flow velocity, yung flow rate, divide mo ng yung cross normal area, which is pi times diameter times the width ng blade. So, kasi kailangan natin yung velocity yan. So, where BF is equal to 4,000 kilogram per second over 1,000 kilogram per cubic meter para maging Q, pi times 0.8 times 0.25 BF1. So, BF1 is 6.37 meters per second. So, nakita nyo itong, yan yung BF. Yung tawag. Mag isang 90 degrees sa blade. Okay. So, yung velocity triangle, may kanya-kanyang tawag yung velocity dyan. So, flow velocity is equal. So, equal siya. So, B sub U1 is equal to U1 plus BF1 over tangent beta 1 or 80. So, B sub U2, kayo na lang mag-ano kung kailangan lagi tayong may mga equation. Ito kasi sa example. So, doon sa book. So, B sub F1, B sub U1 is 16.34 plus 6.37 over tangent 80 is 17.46 meters from the triangle. So B sub F1 over B sub U1 is tangent of alpha 1 is 6.37 over 17.46 is tangent of alpha 1. So alpha 1 is 20.04 degrees. So the jet should be inclined at this angle to the periphery of the wheel. So may answer ka na. Lagyan natin answer. Lagyan mo answer dito. Lapit na tayo. So, ito pa figure 8 tayo. Figure 8. Now, B1 sin alpha is equal to BF1. So, B1 is equal to BF1 over yung flow velocity to sin alpha. 1 is 6.37 divided by sin of 20.04 is 18.59 meters per second. So, meron tayong B sub 1. As the blade width is constant, the flow velocity at exit is 4,000 over 1,000 times pi times 0.4 times 0.25 plus BF2. BF2 is equal to 12.73 meters per second. So, lalaki kasi siya kasi yung radius mo lumiit. So, tangent beta 2 is equal to B sub F2 over U2 is equal to 12.73 over 8.17. So, beta 2 is 557.31 degrees. Yan. Iba yung B, beta yan. Beta 2 yan.
at this figure. Okay, figure 9. Okay? Yan. Dito sa diagram sa ano, sa velocity exit triangle, makikita mo na yan. So, as exit is radial, B sub U2 is equal to 0. Yan, radial. As BF2 is equal to B2. Okay, radial. So the torque is equal to M times R1 B1 cosine of alpha 1 minus R2 B2 cosine of alpha 2. So is equal to M dot times R1 B sub U1 minus R2 B sub U2 is equal to M dot times R1 B sub U1 minus 0 kasi B sub U2 mo is 0. So therefore M dot R1 B sub U1 yan sa turbine, di ba? So 4,000 times 0.8 over 2 times 17.46 equal to 27,936 Newton meter. Kaya later sa hydraulic turbine, babalik tayo dito. Yan na lang ang equation natin na naiiwan sa hydraulic turbine. Kasi may doon mga radial. Radial, ibig sabihin, ito, lumabas siya ng ganyan. Radial. Yeah. So, kaya dito, yun ibig sabihin. Yung iba, hindi siya naka-vertical o kaganyan siya. So, hindi yun radial. Next is the power is the WT is equal to 2 pi n over 60 times T or 2 pi over 60 times 390 times 27,936 is 1,140,926 watts. So P is equal to 1,141 kilowatt or P is equal to M dot times B sub U1 minus B sub U2 So is equal to M dot times B sub U1 is 4,000 times 17.46 times 16.34 is also 1,140,926 watts or 1141 kilowatt. So we can also determine BR2 and BR1 if required. So answer. So blade outlet angle is equal to beta 2 is 57.31. Angle at which the water should flow for smooth entry is alpha 1 is equal to 20.04. So sa summary of answer, sunod-sunod na yung sagot mo. Okay? Torque exerted and power T is equal to 27,936 Newton and the power is 1141. So hindi na nailagay dito. Okay? Basta meron yan dito. Ayan. Okay? So sa solusyon, narambol pero pagdating dito, isa-summarize mo yung sagot mo para masagot mo yung required. Hindi mo nasasagot yung required kung hindi mo sinamarize, puro ka lang solution, wala nga answer. Okay? Kaya sabi mo, andun po sir yung sagot sa solution. So hindi mo din-declare. Okay? So okay, so this is the end of this topic. So ayan yung mga velocity triangles from the internet and the pump. Okay, thank you very much.